Okay, so just for this quick little resource, I felt that I might be able to help alleviate student difficulties when thinking about how we use auxiliary views in roof geometry. So, from students should be well familiar with the term of auxiliary views and what they are, but I want to bring it into context as to how we use them when in roof geometry. So, using auxiliaries to see the true length of a line between two surfaces. So, normally what we're being asked is, in the correct term is, it might be asked the valley or the line of intersection between two roof surfaces. We will be told to find the dihedral angle between those two surfaces. So I'm using this resource in order to help students to recap over what they simply know already. So what we know from studying auxiliary views in junior cycle and for leaving senior cycle is that we're finding the true length of a line. We need to look directly at a view that gives us straight on view of that line. So for example, when we're looking at a line view floating, we can say that the true length of the line we can see in elevation if the view in plan is parallel to the XY line. So you can see that from this model I've just simply made on PowerPoint slides, what I've done is I've created a vertical and horizontal plane, and from the view directly down in plan, we can see that the line is parallel to our XY line. Therefore, from elevation, we're given the true length of the line AB. So parallel to XY line in plan gives us the true length in elevation. Then in reverse way, it's parallel in elevation, we will find the true length of that line in plan. So if we were to look directly down, we can see that the line AB, the true length of that line will be given in plan because our line in elevation is parallel to the XY line. But then we get to a scenario where the line is neither parallel in plan or elevation. So therefore, none of the line views given are going to give us the true length of the line. We need to be able to project off another view. So what we need to do then is we need to look directly at our line in order to give us a true length view of that line. So the first auxiliary project will give us the true length of the line of it as an edge view. This projection is perpendicular to the line of intersection. So the auxiliary plane that we've created, what we projected on is going to be perpendicular to our line of intersection. By finding the line as an edge view, we could then project a second auxiliary. So first auxiliary projection, we projected perpendicular to our edge view. So our dashed red lines will be perpendicular to our true length. And the second auxiliary, we can then see this line of intersection as a point view. This second auxiliary is taken parallel to the true length of the line of intersection. So we've got our view of true length, and we're going to project a new plane AP2 that is parallel to the view we look at is parallel to the true length. Therefore, we will be able to see the line as a point view, giving us the information we need to be able to complete the dihedral angle between two surfaces. So in a recap is first auxiliary perpendicular, second auxiliary parallel.